Hi, Dr. G here. This video is on converting between exponential and logarithmic equations and also solving some basic logarithmic equations by first converting them to exponential and using the one-to-one property of exponential functions. So first let's start with the definition of a logarithm. The definition of a logarithm uses an exponential equation. So we're starting with a positive number b that is not equal to 1. So whenever we have an exponential equation, we have a base b, which has to be positive and is never equal to 1. And whenever we have a logarithmic equation, we have to have a base b, which is positive and never equal to 1. So starting with our base b, the following two equations mean the same thing. They're equivalent. They mean the same thing. They're saying the same thing. The first one is the exponential equation y is equal to b raised to the x. That means the same thing as the equation x is equal to the logarithm base b of y. So let's look at these two for a minute. The numbers y, b, and x in both equations are the same thing. So in the equation on the left, the exponential equation, x is the exponent, right? It's the exponent we have to raise b to get the number y. So basically, in the equation on the right, we're saying that the logarithm of a number base some other number is really the exponent. So always think of the logarithm as an exponent. So the logarithm base b of the number y is the exponent we would have to raise b to get the number y. And so let's see how to use these two equations, how to go back and forth between exponential and logarithmic. So let's start with the exponential equation 81 equals 3 to the 4. Let's rewrite this in logarithmic form. So 4 is the exponent, so that means that 4 is our logarithm. So 4 is equal to the logarithm base, and then we look back at the exponential equation and the base is 3. So it's 4 is the logarithm base 3 of the number 81. So 4 is the number we have to raise 3 to get the number 81. All right, let's do a different one going the other way. Let's start with negative 3 is equal to the logarithm base 4 of 1 over 64. We're going to convert this to an exponential equation. That means the exact same thing. So looking at this logarithmic equation, we identify the base. The base is 4. And then we're going to raise that base to the exponent, negative 3. So 4 raised to the negative 3 has to be equal to whatever is left, which is 1 over 64. And we can verify that. 4 to the third is 64, so 4 to the negative third is 1 over 64. All right, let's convert this exponential equation to logarithmic form. 5 to the x is equal to 1 over 625. So we're going to convert it to an equation that has a logarithm base something is equal to something else. Well, a logarithm is an exponent, so x is going to be the logarithm, and so x is equal to a logarithm base what? We go back to the equation, we go, okay, the base is 5, so x is the logarithm base 5 of what number? Whatever's left, 1 over 625. So we never write logarithm base 5 and just leave it like that. X can't be the logarithm base 5 That's like saying x is the square root. The square root of what? You have to say of something. So logarithm base 5 of 1 over 625. So it can't leave out that number. Right? Let's look at how would we solve that logarithmic equation? Well, we can solve the exponential version. So if we wanted to solve that logarithmic equation, all we have to do is convert it to exponential and then solve that. So the exponential equation is 5 to the x equals 1 over 625. So to solve this, we need to get both sides of the equation in terms of the same base. Notice on the left side we have 5 raised to an exponent. So we want to try to write the right side as 5 raised to some exponent. So first of all, you might remember that 625 is really 5 to the 4. So the right side is 1 over 5 to the positive 4. And now we can rewrite 1 over 5 to the positive 4 as 5 to the negative 4. So we have 5 to the x is equal to 5 to the negative 4. And now we can use the one-to-one property of exponential functions. If 5 to the negative 4 is the same as 5 to some other number, then those two numbers have to be the same. So x has to be negative 4. That's the one-to-one property of exponential functions. All right, let's do some more. So let's convert this logarithmic equation, 6 equals log base 3 of 725, to exponential form. So we identify the base, 3, and the exponent, 6, and write 3 to the 6. And that has to be equal to whatever number is left, 729. Let's try this one. It's an exponential function, an exponential equation. 1/3 to the x is equal to 27. We want to convert it to logarithmic form. So 1/3 is the base, x is the exponent, so that's the logarithm. So we can write x is equal to the log base 1/3 of the number that's left, 27. All right, let's try this. This is an equation that we can solve for x. So let's solve log base 2 of x equals -6. Let's figure out what x has to be. So to solve this logarithmic equation, we first convert it to exponential form. So we take that base 2 and raise it to the exponent -6. Remember, the logarithm is just an exponent. So 2 raised to the -6 has to be equal to whatever that number is, x. And then we're pretty much done. 2 to the -6 is 1 over 2 to the positive 6. So we've got 1 over 64, and that's x. So we started with a logarithmic equation we wanted to solve. So we first converted it to exponential form, and we were able to solve that. Let's try one more. So let's solve log base x of 49 is equal to 2. So we're going to solve here for the base. X is in the base. So let's rewrite it in exponential form. So we're going to take that base x and raise it to the exponent 2. So x to the 2 is equal to 49. And now we've got a quadratic, right? X squared equals 49. So the square root property says x is plus or minus the square root of 49. But we have to remember x was the base of a logarithmic function. So x has to be a positive number. So we have to choose the positive square root of 49. So x has to be positive 7. All right. So when solving logarithmic equations, try to convert to exponential form first, and then you may be able to use the one-to-one property of exponential functions.